We use factory design pattern whenever we want to create real world objects which have the same functionality. To be specific, those real world objects will be sharing the same interface. Take the example of a computer car racing game. So there can be multiple vehicles, there can be cars, there can be trucks, but they will have the same functionality. For example, a common function can be a get image URL. Now, the functionality is the same, but the implementation for that function get image URL, it will return a different 3D image object URL for each of the vehicle. Car A can have a different image URL, car B can have a different image URL, another truck A can have a different image URL. So the implementation of these functionalities will be different. Another method can be accelerate method. So the acceleration provided by each vehicle will also be different. The fuel carrying capacity will also be different. So in this case, it will be better to use a factory design pattern. Another example can be the chess pieces. Here again, we have to create a large number of objects, like 16 objects in total, and each of these objects share the same method, that is the move method, which can tell whether the piece can move from its starting position to a given final position on the chessboard. So the functions name is same, they all follow the same interface, whether it's a pawn or a king or a queen, but the implementation is different. A knight moves 2 plus 1 move. A rook or a pawn has got one move and it kills diagonally. A rook can move only horizontally and vertically. A bishop can move only diagonally. A queen can move in all three directions, any number of blocks, horizontally, vertically, and diagonally. So the implementation for move method will be different in all these cases. And we need multiple same pieces, like 8 pawns of black, 8 pawns of white, 2 knights of white, 2 knights of black. So in this case also, factory design pattern will be a good idea. Another example can be a bank account. There can be thousands, tens of thousands of customers, and the accounts can be of multiple type: current account, saving account, business account. Now these accounts will have the same functionality. All of them will have something called a calculate processing fee, calculate yearly minimum balance, but they all will be calculated differently. Everything will return a different value, all of these methods. So in this case also, using a strategy design pattern will be useful for us. For implementing a factory design pattern, the first thing which we have is the common functionalities, which is an interface. So let's take the example of car. So we have interface car, which has got two common functionalities: get price and get acceleration time. In real world, there can be tens of different functionalities, like get fuel tank capacity, uh, uh, get insurance premium, many things like that. But here, for the sake of example, we will only consider these two functions. And now this car interface is implemented by Mercedes and Range Rover, which give their own custom implementation for the get price and get acceleration time. Now how are they used? We have a class car factory which has got a method get car, and this will take a context which name is id. If id is equal to Mercedes, then we return a Mercedes object. If id is equals Range Rover, then we return Range Rover object, else we return a default car object. So this is a simple implementation of how factory design pattern is used for creating different cars or subclasses of different which classes which implement the car interface. Now what benefits we got from implementing the factory pattern here? The first one is, now the class which is using the Mercedes object and the creation of the Mercedes object, they have become loosely coupled. Earlier, we had to write this new Mercedes code inside the user class itself. So what if we decided to insert a new parameter in the creation of Mercedes object, like type of vehicle? So whether it is hybrid, electric vehicle, or you can say a petrol vehicle. So in that case, we have to go change the code inside the user class which was using the Mercedes object. So there was no loose coupling. Now factory pattern has enabled loose coupling here. Another benefit is the second one is, we have to write this new Mercedes code in all the user classes. So let's suppose earlier there were 10 classes which were using the Mercedes object, this new Mercedes call. So when we try to introduce a new parameter here, then in all 10 classes we have to go and change that parameter, add that parameter. So factory design pattern has removed that thing also. So now we have to make change only in this code, and so the creation code of Mercedes or Range Rover or any car happen independently from the class that is using the Mercedes or Range Rover. So we have loose coupling and we have ease of maintenance. So these two are the major benefits which factory pattern has provided us here. Now let's see an actual interview question. So let's see how we are going to use the factory design pattern in an actual interview question. We have the design chess game, and I have already opened the question. In a chess game, there are multiple different pieces, and this is the blueprint for a chessboard. You have got various white pieces in this side and black pieces in this side. These are all white pawns: white rook, knight, bishop, queen, king. And again here we have black pawn. All these are black pawns: rook, knight, black bishop, black queen, black king, and so on. So how have we implemented it? Instead of an interface, the common functionality is in the class piece, which have this method piece, which has this constructor piece and which have got moves, and this is the can move method which this class piece has. Okay, now this class piece is implemented by different chess pieces: class king piece, knight piece, pawn piece. Other pieces are all created directly from the piece object. We will see how. So now let's come to the chess piece factory object, which actually creates all the chess pieces. We'll just see the create piece method. It takes two parameters. The first one is color and the second one is type. So the color is this WR. WR means white rook. So the first character is W, second character is type. R for rook, B for bishop, Q for queen. So how are the chess pieces created? This method returns the piece object. So suppose it's Q. So it passes the color and the type, and the move is created. So the queen has got two moves: the straight move and diagonal move. Straight means both horizontal and vertical, and diagonal is like diagonal move. Rook has only got a straight move, that is both horizontal and vertical move. Bishop has got a diagonal move, and the rest of the three pieces, king piece, knight piece, and pawn piece, have their own implementation. They are not created from the generic piece object. So this is how the chess piece factory creates objects. Here we have returned null. Generally you refrain from returning null, you return some default object. So here the king, knight, and pawn have got their own implementation for the can move method that we can see. So this is how the pieces are created in a factory. And now how all these are used? They are used from the chessboard method. So you see here a board of size row column is created, which has got the size of this whole blueprint. And then for each row and column, we check if there is a piece there. It means there are at least two characters there, else it is empty. So if there are two characters there, let's suppose WP is there. So we will extract the color, that is the first character W, and the second character type, which is P. And then we will ask the factory to create us a piece and put that in that row column position of the chessboard. So this is how overall the factory design pattern is being used to create all the different chess pieces in this, and this will make things simpler for us. Now design the chess game or low level design game of chess is actually a very interesting question, because it uses very two similar patterns, factory pattern as well as strategy pattern at the same time. So here we also get to look at how factory pattern is different from strategy design pattern, because if you look at the code, both these patterns look very similar. Both have got an interface or a class which contains the common functionality, and the other classes which either extend that generic class or implement that interface. So we need to actually understand what is the real difference from it, else we get confused. People get confused most of the times. So when you look at a design pattern, we have to look at it from two perspectives. First, why that design pattern is being used, and the second is how that is being used. Now how is the code part, which is similar in case of both these patterns. Why? So factory design pattern is being used for creating multiple objects. There can be 8 pawns of white, 8 pawns of black, again 2 rooks of white, two rooks of black. You can see, so there are multiple similar or even same objects are being created, and all of them follow the same interface or have the same method in them. So this is factory design pattern. But in case of the strategy design pattern, let's see how we have implemented it. We have the move interface, which was also there in the piece class. So this move interface means whether a piece can move from a starting position to an ending position on the chessboard. We have classes which have implemented this move interface. We already saw the names of those classes. So these are the classes: diagonal move and straight move. Diagonal move is made by bishop, and queen also makes this move. Straight move is basically your horizontal plus vertical move. It is made by queen as well as rook. So these two are the moves. We have implemented the moves using only these two methods, and we have used these moves to actually create the chess piece objects as well. So we have basically combined strategy and factory design pattern, but the difference is in how these two moves have been used. So let's come back to the chess piece factory object. You will see that a single object of both these move classes are made, and they are basically reused again and again for creating different pieces. So if you didn't see, you can see the same move object is being used to create the different pieces. So this is the difference. Generally, if you want to just see the difference based on the implementation also, generally in a factory pattern, there can be tens to hundreds to thousands or even tens of thousands objects can be created. For example, if it's a computer war game, then hundreds or thousands of soldiers can be created using the factory design pattern. If it's a text uh, uh, basically a text editor, there can be 10,000 to 100,000 characters in the, and there also we can use just factory design pattern. But in case of a strategy design pattern, there will be hardly 3-4 different algorithms, and all of them will be reused. So if you are creating new algorithms which have the same functionality, use this strategy. If you are using real world objects for the same functionality, use factory. This is the difference between these two. I hope you understand. Let's move ahead. So if you want to take just one thing from this video, then remember that we should use factory design pattern when we want to create similar real world objects that, and they are having the same functionality. That is, they follow the same interface. That's it. So this was about factory design pattern. I have created a 7-day plan for preparing for your low level design interviews. You can access it on codegym.com/roadmap. This will help you prepare for your LLD interviews efficiently. It has got short videos on a day-to-day basis, and on each day there is a practice problem. So there is basically, when interviews are scheduled by the recruiter, there is very less time. So people are confused which videos they should see or what they should read and what questions they should practice, because there is tons of content on the internet, lots of videos on the YouTube, and time is of the essence. So here you have got all at one place, the theory as well as the practice part, and so your interview preparation will be smooth and much, you can say it's a smart way to prepare. So do give this a try, and I wish you the best of luck for your preparation. Thanks for watching this video. Bye.